In this example, we're asked to find the cardinality of the power set of the power set of the power set of the set X. And the set X is given to us. It's given in list notation by just the elements A and B. So that means the cardinality of X itself is just 2, right? Remember, the cardinality is the number of elements in the set. So the cardinality of X is 2. And then we're asked to find the cardinality of the power set of the power set of the power set. And we're going to see when we get to our answer why we do not want to actually write out every single element of this set, this power set of the power set of the power set. But what I would like to do is write out at least the first few terms of the second power set for sure. So let's start with the first power set. Remember, the power set is the set of all subsets, and there are 2 subsets that are always going to be included, and they're called the trivial subsets. They are the empty set, the set that has no elements, right, and the entire set itself. So we'll get to that in a second. But the other subsets here of this 2-element set are the individual elements themselves, and these are called singletons because they have only one element, right? So the singletons, A and B. And notice that you need the braces around these because this is the set containing A and the set containing B. It's not just the element A and the element B. So we're up to 3 here, right? And then finally, we get to our complete set X, right? Which this can just be written as the set containing A and B, but that's X itself, right? Now, by the way, at this point, the cardinality of P of X, the power set, this one is 4, right? There's 4 subsets here. There's 4 sets, I should say here, 4 elements of the power set. So at this point, what we want to do is start to write out the first few terms of the power set of X. Now, the reason I want to do this is because there are some subtleties that we have to deal with this empty set here. First of all, before we even get to that, let's remember, right, that when we take the power set of anything, so we're trying to find all the subsets of this P of X, right? When we take the power set of anything, we know that there are always going to be 2 elements in here. There's going to be the empty set, and then eventually there's going to be the entire set itself, right? So the entire set P of X. All right, but then we have to build all the other subsets. So the other subsets are the singletons of the elements of this. So some of the subsets are the singletons of the elements of P of X. Notice that the empty set is itself a member or an element of P of X, right? And so the next subset here is the set containing the empty set. That is very different than the empty set itself, right? The empty set is the set that has no members or no elements, and the set containing the empty set has an element. It has the empty set as an element, right? So it's a little subtle here, but that's how it works. And then we go on from there. So the next subset is the singleton whose element is the singleton. So notice I need double braces here. I need the set containing A. Same thing for B, right? The set containing B. And then we have the last singleton here is the set containing the set that contains A and B. All right, and then there's a whole bunch more. You can do the doubletons, the tripletons, and then eventually we get to the whole power set. We could write all of those out. We don't want to. So the main reason for writing those out in this example right here was to discuss some of these subtleties here with taking multiple nested power sets. But it turns out, so we have a formula for this, by the way. It turns out that the number of subsets of the power set, right? The number of power, the cardinality, let's just call it what it is, right? The cardinality of the power set is, we can get this by a formula, right? And so here's what our theorem in the note said. So if the cardinality of A, I'll use A because we already used X for something else, is equal to N, right? Then the cardinality of the power set of A is equal to 2 to the power of N. All right? Or another way to write this so that we can see everything all at once is that the cardinality of the power set of a set A is equal to 2 to the power of the cardinality of A. And by the way, this is one of the reasons that it's called a power set, because the number of elements grow exponentially, right? So like a power of 2. All right, and just based on what we've done already, we see that this holds for the first couple, right? The cardinality of X is 2. The cardinality of the power set of X is 2 to the 2, which is 4. All right, and so now, just based on this, we can compute the cardinality of the power set of X, right? And I'm going to color code this a little bit. Remember, this is the set that we're trying to take the cardinality of the power set of. So by our formula, this is going to be 2 to the power of the cardinality of the power set, right? So see how the colors match up here? What's inside of the outermost power set, that's what goes up in the exponent. And we just computed that this is 4, so this is 2 to the 4th power, and 2 to the 4th power is 16. Okay, so there we go. That's the cardinality of the power set of the power set. That, by the way, is only the cardinality of this much, right? We want to extend this out and get the cardinality of the entire, the triple power set in some sense, right? 3 nested power sets. So we go on. We can keep using this formula. We definitely don't want to write this out because now this power set has 16 elements, right? You can probably already guess what the answer is going to be to this question. But the power set of the power set of the power set of x, when we want to take the cardinality. By our theorem, this is the number of elements is 2 to the power of the cardinality of that term, right? And that term in this case is the double nested power set, so the power set of the power set. And we just computed that that number is 16, right? And so the power set of the power set of the power set, the third order, in some sense, a nested power set of a set that started off containing 2 elements, already at this point is up to 2 to the 16th power in its number of elements. All right, and you definitely would not want to write all those down. It would take you a long time to do it. It's a finite number, so you could eventually do it, but it would take a long time.